Okay, so let me go ahead and go over what I expect from this. We're entering the most active period of severe weather season in Oklahoma. I'm going to be focusing mostly or entirely on Oklahoma's severe weather. This is not a storm chasing how-to. I asked Julia earlier if I could take a state vehicle and lead a caravan on a storm chase, but she shot that down really fast. Almost, it was actually kind of hurtful how quickly she shot that down. But
only if I can go. Come on, be honest.
Fair enough. So again, I want to focus on why we have severe weather in Oklahoma, where to get the information regarding current and future events, how to protect yourself, and then we'll also look at some tools to interpret current severe weather situations and the best way to protect yourself during the storm season. So with that, I need to make a disclaimer. And that disclaimer is that I am not a meteorologist. Maisie isn't a meteorologist either. In fact, Maisie, she's kind of dumb, but I only know a little bit more about meteorology from her than her. So it gets kind of frustrating as we get into the severe weather season. 4 or 5 people ask me every day, will there be tornadoes today? What's your thoughts on the severe weather situation today? My disclaimer is I do not want to be your source of information. I can only parrot what other people tell me. Yeah, I know some of this somewhat, but I'm not a meteorologist. I'm not a forecaster. So the only time I'll ask you guys to unmute yourself is right now. For one last time, I want everyone on 3 to ask me, will there be a tornado today? 1, 2, 3.
Will there be a tornado today?
No. All right, everyone mute yourselves. That's the last time I'm going to answer that question. So while I'm not a meteorologist, I have done a lot of work learning this stuff, how to position myself in front of these storms. And in doing so, I've been able to see some really cool things. Now, like I said, this is not a how-to on storm chasing. There's plenty of guides out there. This is only about why we get severe weather and how you can protect yourself. So I'm sure you guys have all seen this before. Can you see my mouse? I just want to make sure you can see the mouse. All right, yeah. I knew Maisie would be very popular. So if you've been in Oklahoma, if you looked at severe weather, this is a graphic you've seen a lot. Basically, severe weather is what happens when warm, moist air from the Gulf meets cold, dry air from Canada in the Arctic. We also have this warm, dry air pocket coming from the Chihuahuan Plateau and our jet stream, which is fast winds that are a few kilometers above the surface, come in like this. Now, we also get this warm front, which usually moves north, and a cold front coming in behind it. But this is really, really important for most of us Oklahoma severe weather. This is the dry line, and that's a term you'll hear a ton throughout the spring. And for us, this dry line is a critical component for severe weather. Now, what I'm going to do is I'm going to go a little bit deeper into this. But first, let's kind of review where severe weather happens. So this is from the National Weather Service. These are all the tornado reports from the year 2019. Now, unfortunately, Mississippi won the dubious award for most tornadoes in a single year. And in the lower 48, as far as I can tell, only Utah, Rhode Island, and Vermont did not have a single tornado report. Now, a lot of these, especially out east, are very weak, brief tornadoes or land spouts, but 2019 was definitely an above average year in terms of tornado reports, especially around Tulsa, in the Texas Panhandle, southwestern Missouri, the Deep South. These were all very active areas, and it shouldn't be that surprising that these areas are getting these tornadoes. And this is just the average number of tornadoes per year on within a state. Oklahoma averages about 62. which, as active as Oklahoma can seem, that may not seem like a lot, especially with Kansas getting about 96. I think Kansas per square mile gets the most strong tornadoes in the United States, but Oklahoma is not far behind. Texas, just based on size, gets a ton. But here in the Deep South, Alabama and Mississippi, they average quite a few as well. So tornadoes are not just a plains thing. They occur throughout the year in many different parts of the country. Now, this is the tornado probability for today, based on a almost 30-year average. So the Deep South, their tornado season is starting to increase, and ours is as well. April is really kind of the beginning of the prime time for severe weather. And what I'm going to do is I'm going to come over here real quick to a video showing how the tornado threat changes throughout the year. So in the winter, it's usually confined here in the Deep South. Our first tornado outbreak occurred in Louisiana, Mississippi, and Alabama on January 11th this year. And that lasted a couple of days. And there was another killer tornado in Alabama in February. Then we had a killer EF4 tornado occur here in Tennessee on March 3rd, I believe. And so now we're getting into the active portions of the year. And on March 28th, there was forecasted to be a severe weather outbreak up here in Illinois. Morning rainfall killed that potential for the most part. But that same day, there was a really strong tornado that went through Jonesboro, Arkansas. But like I keep saying, as we get into April, you can really see the bullseye starting to develop here in Oklahoma. And as we get into May, it really peaks. For those of you who have been in Oklahoma for a long time, May is definitely our biggest year, or our biggest month in terms of severe weather. But April and June also can have their big events. Now, as we get into the summer months, that threat shifts north. This is when the northern plains and into Canada starts getting their severe weather season. But as a high pressure system builds over Oklahoma, that starts decreasing into the later summer months. But an interesting thing occurs here in August and September. A more confined active stretch begins here in the coastal states. Now that's kind of weird. Does anyone have an idea why that may be? Why is there an uptick in tornado potential on the coast in September? Anyone have an idea? Yep, Derek Stark absolutely nailed it. Hurricanes, yeah. Hurricanes are often associated with tornadoes, and few of them can be very strong. So as we get back into September, there may be a little bit of an uptick in threats for the southern plains, but we really begin to see that shift back into Dixie Alley over the winter months, and then the whole process starts again. Oh, hold on. Let me kill that real quick. Cancel. All right. So unsurprisingly, that bullseye showed that May, it really is our month to be the most weary about. But April and June are also there. And we have tornadoes occur in every single month. Granted, they're much more rare in the winter and summer months, but there's still that possibility. And this is what Oklahoma can look like in May. We can get these large, violent tornadoes that destroy entire neighborhoods or hurt a lot of people. But it should be, I want everyone to be aware, these are the exception. Most tornadoes are very small, they're very weak, they don't hurt anything. But you always have to remember, especially in the summer, that these kinds of tornadoes are a possibility. But also don't let your guard down just because the calendar says it's not spring. This was a violent EF4 tornado that occurred outside the town of Tipton in southwest Oklahoma. The date of this was November 11th, 2011. Here's a killer tornado that struck the small town of Lone Grove back in February of 2009. So May is our most active month, but the calendar, if the meteorological setup is there, The calendar does not matter. So we're going to focus mostly on what's called a supercell. Now, there are thousands of storms every single day across the globe, but what separates a supercell from an average, pop-up thunderstorm is this. Now, every thunderstorm has an updraft, and this is warm air at the surface being lifted up into the atmosphere, condensing and creating clouds. What separates a supercell is that it turns. The updraft is spinning in a supercell. Now, that's extremely rare. There might be a couple thousand supercells across the globe every year, but the United States, especially the plains and the deep south, these are much more common than anywhere else in the world. And we're going to kind of go into that here in a bit. But there's a couple of things I want you guys to focus on. So the updraft is where air at the surface is being lifted up and it's tilted. So when it's tilted, what goes up must come down, and some of that falls in front of the updraft base where the tornado would most likely form. And we call that the forward flank downdraft. So in this case, the storm is moving from left to right, as shown by this. This is your area of the most heavy rain. This is your largest hail. But also some of that energy comes out from behind and into the rear flank downdraft. And the rear flank downdraft is hypothesized to be one of the most important parts of tornado development. As this air comes down, it gets pushed back into the updraft, stretches the updraft, and creates this tornado. Now, there's still a lot of debate. Why some cells create tornadoes, why some in the same atmosphere don't. That final mechanism is still kind of not known, but the rear flank downdraft definitely has an important part of it. So this is looking down on a supercell. Here's the updraft here. And the forward flank downdraft on radar, this will be your highest returns of reds and deep oranges. This is where you'll get your largest hail. This is where you get some very strong winds. And then the rear flank downdraft kind of comes in and curves around the back end of the updraft. And this is where you get your hook echo. If you've ever heard the term hook echo, that's the rear flank downdraft wrapping around the updraft like this. And your tornado is going to be most of the time in the northern hemisphere at the northern end of this hook. So this is what a supercell looks like in the real world on radar. This is the Tuscaloosa EF4 from April 27, 2011. You got your forward flank downdraft here. So this is where you get your highest returns. This is your heavy rain. This is your hail. You can see the rear flank downdraft coming in around the tornado. And what's happening at the surface is you also get this inflow band. And so this is often called an inflow notch of clear air. And that's feeding into the tornado. And this circular thing right here with the really, really high reflectivity returns, that's debris being wafted into the air. The radar cannot differentiate boards, 2x4s, leaves, roofs, or whatever from just really heavy rain. So it interprets it as very heavy rain, but in fact, that is a destructive tornado occurring on the ground. So I mentioned the EF scale. So every tornado is rated by the damage it causes. And this is often a source of confusion. The EF scale, or the enhanced Fujita scale, is a damage scale. It is not a wind speed scale. If a tornado does not hit anything, it gets rated an EF0. But even large tornadoes, if they don't hit anything, will be lower or rated lower than they would if you put it into a populated area. So let's say you take the Moore EF5 from 2013 and you put it in the middle of nowhere, South Dakota. It doesn't do anything except knock over a few corn stalks. That's going to be rated probably an EF1, EF2, just because of the ground scouring that it caused. But it's not going to destroy any large buildings, well-built buildings, so it's not going to get that really high designation. The F in Fujita, that is named after Dr. Ted Fujita from the University of Chicago. He was the first one to really start analyzing what kind of damages are caused by certain tornadoes. And so we consider EF0 and EF1 tornadoes weak, EF2, EF3 tornadoes as strong, and EF4, EF5 tornadoes as violent. Now, 85 or so % of tornadoes are weak. These might rip some shingles off, these might break a glass, your windows. They're not going to cause the significant damage, whereas the violent tornadoes make up less than 1% of all total tornadoes that occur. But the vast majority of fatalities are caused by these EF4, EF5, or even EF2, EF3 tornadoes. So almost 90+% of all tornadoes fatalities are related to these strong to violent tornadoes. And yeah, I'll mention significant tornadoes in the future. That's anything EF2 plus. So there are a billion things that go into making a tornado, but we're going to focus on the 4 main things. And in that case, in order to make a tornado, you're really going to need moisture, instability, wind shear, and a source of lift. Now, moisture, it's measured by the dew point, and the dew point is the temperature at which the air temperature has to get to in order for condensation to occur. So if you have a glass of water and it starts condensating, that just means that the air around that glass is reaching the dew point on that glass. Now, for severe weather, we're looking for dew points around 55 degrees or higher. That's not a dead set thing. You can get severe weather with dew points lower than that. But if I'm forecasting, I really want to start seeing 50, mid to upper 50s. And for tornado potential, that starts maximizing around 60 degrees. And for the really big, significant tornadoes, I'm starting to look at 65 plus or so. And this is a dew point map from a tornado outbreak that occurred in southern Oklahoma back in 2016. You can see this gorgeous dry line. Now, the dry line, you had this warm, hot, dry air back here, north-south, and then you got this really large, moist atmosphere in front of it. And as this dry line starts moving east, that's often the source of your isolated supercells. And in fact, on this day, there was an EF4 out here by Wynnewood and an EF5 capable tornado out here by Sulphur. Instability is a little hard to understand. It's measured in CAPE, which is convective available potential energy. It's basically a measure of how badly the warm, moist air at the surface wants to move up into the cold, dry air above. Don't worry about this too much, but usually 1,000 joules per kilogram is needed for severe weather, 1,500 for tornadoes, and 2,500 for significant tornadoes. Again, that is not set in stone. There have been violent tornadoes with 800 joules, 800 CAPE. So that's kind of just a quick glance measure of what we're looking for. And on this day in 2011, there was a tornado outbreak in Oklahoma. The CAPE values were measured around 3,000. And we will come back to this, I promise. This was an important day. Wind shear is also a little difficult to demonstrate, but it's basically a change of wind direction and speed with elevation. Shear is measured in knots, but I think a more useful term for people just getting into this is a term called storm relative helicity. We will go over this again. This is in meters squared per second squared. For just tornadoes in the lower 1 kilometer, you're looking for SRH around 100. For significant tornadoes, about 150 or more in the lower 1 kilometer. 0 to 3, 250 meters squared per second squared. Not set in stone, but I think this is usually a much better indication of significant tornado potential if the other things are in place. Now, source of lift, usually cold fronts undercut the inflow to the storm, really killing them, causing a line of storms. Warm fronts are more of a Midwest thing. So my Indiana, Illinois, Iowa friends, they love warm fronts, but they can be large. They can produce large tornadoes, but they can also be really messy and kind of hard to predict. But for Oklahoma, I think the dry line is really what separates our severe weather from severe weather across the globe. And we will go over this a bit. Outflow boundaries are another thing. Those are really difficult to explain. We're not going to worry about that. That's a very specific case for the most part. So this is kind of our broad setups in the jet stream during the fall and winter. So we have a low pressure system, which should really be further into Canada. And in the northern hemisphere, low pressure systems spin counterclockwise. So that means high pressure systems spin clockwise. And what happens is our jet stream kind of is funneled in towards the Gulf of Mexico. Now, I've said before, the Gulf of Mexico is our source of moisture, but these crashing cold fronts really, really contain that moisture down here during the fall and winter. That's why you get that dry Arctic air coming in during the winter months, and that mostly limits the severe potential. Now in the summer, the jet stream does this doohickey because this high pressure system sets up over Oklahoma like this. So that causes this, what was called an omega block for those storm chasers who might be listening. And this is why you really want this southwest flow to meet with your moist air. So this is why it's kind of limited to northern plains in Canada during the summer. But for the spring, something really interesting happens. You get this high pressure system here. So clockwise movement of air there forces that warm moist air from the Gulf into the southern plains. And then you got your jet stream coming in like this, creating southwest flow, meeting northeast flow from the Gulf. So at the surface, like I said, we got our warm moist air moving to the northeast. And then above that, about a kilometer above the surface, we have this warm dry air coming from the Chihuahuan Plateau, New Mexico Plateau, something like that. This is key for our bigger severe weather events, and we'll kind of go over this here in a sec. And then above that, we got this southwest flow coming from the jet stream. Now notice how the direction of the wind changes with height. So at the surface, it's out of the southeast. A little bit above that, it's out of the southwest. And above that, it's almost due out of the southwest. Above that, it's almost straight out of the west. And so this is what real world data looks like. Every single day, twice a day, every National Weather Service office releases air balloons. And these balloons go up into the atmosphere. They record temperature data, which is this red line right here, and the dew point, which is this green line right here. It also measures the direction and intensity of the winds with height. So this balloon was launched from the surface, had a winds about 10 knots, and it creates this almost sickle shape curve. Now, this is incredibly important in our severe weather. You want this sickle shape in what's called a hodograph. And this is, like I said, it's just the wind speed at elevation. And so here we have our warm, moist air at the surface. It wants to move up, but then it reaches this. And this is an inversion, sometimes called the EML, well, winds, coming out of the southeast right here, about 10 knots. And then above that, you got, stupid mouse. Above that, you got this inversion right here. This is called the elevated mixed layer, or CAP. And what this does is it prevents that warm, moist air from trying to reach this colder, drier air, limiting storm development until usually midday. And that's when you get your explosive updrafts. That's when you get your significant severe weather if this cap can break. And those winds are coming out of the southwest at about 30 knots. And above that, you've got your cold, dry air with winds a little bit faster than that. Now, this isn't the most spectacular sickle shape, but on this day, May 24th, 2011 at 1 p.m., this was forecasted to become much more significant and much smoother. And this was forecasted to be a big time event. Now, also you got this dotted line right here. This is the path that a saturated parcel of air wants to take from the surface. But because of this cap, because of this dryness here, this gap between this dashed line and this red line, that's our CAPE. That's our measure of instability. And so that is calculated for us. You can see the CAPE values here. What did I say was a good CAPE value? Around 2,500 for significant tornadoes. In this case, it was over 3,000. So it is an extremely unstable atmosphere. And I was saying, about 150 SRH for significant severe weather? 166 is there, but it was forecast to get even stronger as the day went on. So my question to you is, did anything happen on this day? Supercell's developed out on the dry line in western Oklahoma, and I want you to focus first on this guy up here. This is the Canton EF3. That was probably a violent tornado. And then next was this guy, which is the Piedmont El Reno Guthrie EF5. So that was truly a violent long track tornado. Here we got the Chickasha EF4 developing, which probably was capable of EF5 damage. And then the Goldsby Washington EF4, which also could be argued had the potential for being an EF5. Now, as the day went on, these storms started to interfere with each other, really limiting the threat further east of I-35. All of this area out here was under a high risk for tornadoes, but because of that interference, they weren't able to establish much anymore, limiting the threat out east. But it's not hard to understand why out here in western Oklahoma, this was a much bigger deal. There was nothing going to stop these things from about the I-35 corridor to the Arkansas state line if they did not interfere with each other. So on this day, there were only, I put that in quotes, 12 or so tornadoes, but they really packed a punch. The EF5 rolled a 1.9 million pound oil rig 3 times. These were probably capable of EF5 damage. That one probably was as well. So this was a truly significant outbreak in central Oklahoma. Now, let's move on to where you get your weather information. Every time there's a big tornado event, there's headlines of "we had no warning" or "we only had a few minutes of warning." That's not true 99% of the time. Big time severe weather events can be forecasted days or even weeks in advance if everything starts lining up correctly. So I want everyone here to check weather information daily, but especially during the spring. And if there's one place I want you to go every single day, it's right here, spc.noaa.gov. Bookmark this, check it daily. If there's a threat for severe weather in Oklahoma, check it multiple times a day. These are the best forecasters in the world who dedicate their lives solely on forecasting severe weather. So they do this 24/7, 365, and they produce outlooks, and these are the guys who issue the severe weather watches. So today is always day 1. Tomorrow is day 2, and then 2 days from now is day 3, and so on. There is a forecast issued every day for 3 days or more in advance, twice a day for tomorrow, and then today there will be 5 separate forecasts issued. And they issue these things by risk categories. So today there's a marginal risk for severe weather in, I think, South Dakota. We're not under any kind of threat. But as you get further and further right, you're talking about more widespread, more significant severe weather. And once you get to the moderate and high risk, you're starting to talk about outbreaks, either regional or widespread. And so let's go ahead and look at the Severe Weather or the Storm Prediction Center webpage today. So like I said, we got a marginal risk of severe weather up here in Nebraska and South Dakota. But every day you can come down here to this tab at the bottom of the Outlook, and you can read what are they thinking is going to happen. This is a really boring day, no one cares. But you can also see the threats by tornado probabilities, wind probabilities, and hail probabilities. So this marginal risk is for a 5% chance of a hail report within 25 miles in this risk. It's not that big of a deal right now. Friday, there's a slight risk down here in southern Texas, and we can look at probabilities of there's a 15% chance of severe weather somewhere in this area. But right now, it's not that impressive. Now, if there was a watch issued, you can come over here to the watch tab, and then there's something called a mesoscale discussion, which there's not one today, but we will go over this as well. So again, bookmark this, visit it daily. It takes 5 minutes. It keeps you up to date with everything. So the risks are done by probability. So what is the probability of severe weather within 25 miles of a single point? If you have a 15% chance of significant EF2 plus tornadoes within 25 miles of an area, that's going to get a moderate risk. 30%, it's going to be a high risk. If you have a derecho or significant severe wind threat, that can also go high risk. You cannot go high risk just based on hail, but you can absolutely go moderate. So once you get into the enhanced or higher categories, you really got to pay attention even more so than you already were. So like I said, SPC, they issue the watches and they issue watches. Now a watch just means that the ingredients are in place to create severe weather. And the warnings are done by more local offices. We will go over that too. So a watch just means the ingredients are in place. A warning means that the severe weather event is happening. So there are 4 types of severe weather watches. Your typical severe thunderstorm watch, hail over 1 inch in diameter or about quarter size is considered severe. Winds over 50 knots or 58 miles per hour are considered severe, and all tornadoes are considered severe. So a severe thunderstorm watch just means hail or winds are most likely the biggest threat, but you can't discount the possibility of a tornado. Now a PDS or particularly dangerous situation severe thunderstorm watch usually is reserved for widespread wind events, derecho or a significant bow echo line of storms. You can still get tornadoes in there, but the main threat is going to be the wind. Tornado watches just mean a severe thunderstorm watch, but there are more than one tornado possible. Usually a typical tornado watch, they're not expecting any widespread outbreaks, but they issue probabilities too, and we'll go over that. But the big headliner is always a PDS tornado watch. This means that not only is there a high chance of tornadoes, there's a high chance of significant EF2 plus tornadoes that could be long track and particularly violent. Potentially violent, sorry. So here's a run-of-the-mill tornado watch from earlier this month in March. So, you know, not that big of a deal, but if you come up here and come to the probabilities tab, you can see, you can see the probability of each severe weather threat. So in this case, there was a moderate threat of 2 or more tornadoes and a 1 in 5 chance that you even get one of those being a strong tornado. Not particularly dangerous, but if you're within a tornado watch, you still need to pay attention. You know, an EF1 tornado can flip a car. So you still need to get a way of getting information regarding ongoing severe weather events. So let's do a case study, and this is the May 24th, 2011 event here in Oklahoma. 4 days in advance, 4 whole days in advance, the Storm Prediction Center put out this risk, highlighting eastern, central Oklahoma and Kansas, and the wording was kind of impressive. Considerable strong severe storm development, including potentially tornadic supercells. 4 days in advance, that's impressive. Now, 3 days in advance, they issued this slight risk, but if you go to the probabilities tab, there was a 30% chance of severe weather in this area. And anytime you see this hashing pattern, that means there's a significant severe weather threat. EF2 plus tornadoes, large hail, strong winds. At the time, they didn't have the enhanced category. So today, if that were issued, this whole area would be enhanced 3 days in advance. So 2 days in advance, they issued a moderate risk. So a moderate risk is the second highest level they could go. All the alarm bells were going off at this time. We're expecting a severe weather outbreak in central Oklahoma, eastern Oklahoma, and eastern central Kansas. There was a 45% chance of significant severe weather occurring somewhere in this purple hatched area. Big time weather event, everyone should have been paying attention. What did I say the dew points were necessary for significant severe weather? 65? Well, this is a dew point map from that day around 4 o'clock in the afternoon. We have upper 60s and 70s occurring in Oklahoma. You can see this gorgeous dry line setting up in western Oklahoma. This was going to be the focal point of these storms going off. And we've already seen the Cape measurements of over 3,000. So we have a very unstable atmosphere. The wind shear was going to be in place. There was a focused dry line. You have your source lift, instability, wind shear, moisture. Everything was in place for a big time severe weather event. So once again, looking at the real world data, this photograph was expected to become more sickle shaped, meaning that the SRH was going to increase a lot. So unsurprisingly, they went high risk this day for central and eastern Oklahoma. And not only that, this is the tornado probability. Anything above 30% is considered high risk. They went one step higher and issued a 45% chance of a significant tornado occurring within 25 miles of any point along the I-35 corridor. So yeah, everything was in place. Every meteorologist was looking at this thing, and this is going to be a big day. So I mentioned the mesoscale discussion. This is issued usually about an hour or two before a tornado watch is issued. It just kind of goes over what the severe weather forecasters are looking at, what's in place, what's expected to occur. And anytime you see wording like favorable for tornadoes, the SRH storm relative felicity increasing to 400 to 600, long track tornadoes are expected. So this is the most dire type of wording that they will issue. And so again, not surprisingly, they issued a PDS watch for central Oklahoma and North Texas. And the wording that they used in the description of this watch was impressive. Destructive tornadoes, Cape values of 2,500 to 4,000, SRH of over 400. I said 150 was necessary was ideal for long track significant tornadoes. We're almost double or tripling that. So again, the final sentence here: threat for tornadoes this afternoon and evening, some of which could be long track and violent. This was a big deal. There was a high chance not only for tornadoes, but significant tornadoes as well. And the way it verified, yeah, you had this outbreak here along the I-35 corridor, some here in North Texas, some here in Kansas, but mostly eastern Oklahoma was spared because of that destructive interference between the storms. However, there was also an EF4 that went through western Arkansas in the overnight hours. So this was a big time outbreak that was forecasted days in advance. This should not have taken anyone by surprise. So we talked about who issues the watch and the forecast. Let's talk about who issues the warnings now. So everyone in the United States is nearby a National Weather Service office. They provide weather information year-round, not just for severe weather, winter weather, fire weather, heat danger, flooding, all that. And on big-time severe weather events, they will coordinate with the Storm Prediction Center to get that word out. And like I said, these are the guys who issue warnings. For us here in central Oklahoma, the NWS office in Norman is our main source of information. They also cover the Wichita Falls area. For the Panhandle, Amarillo takes care of that. For most of eastern Oklahoma, Tulsa is their weather office. And for some reason, Shreveport gets is this McCurtain County, I believe? I guess there is one part in the Oklahoma Fund. So this is what the National Weather Service website in Norman looks like. I would also bookmark these guys. They will provide a lot of information as well. In fact, let's go over there right now. This is what the page looks like today. So here's our temperatures for the next week. I also see a lot of they issue graphics for Precipitation for Thursday, Friday, and graphics like this for planning your week. If you really, really want to get into the weeds, you can come up here to the forecasters discussion and read what they're thinking. This is boring, no one cares, but on severe weather days, you can read this to kind of get a better idea of what they're expecting. So a tornado warning is always issued by the local National Weather Service office. For us, that's Norman. It just means a tornado is in progress or could be soon. They can be issued because radar is indicating that there's significant rotation or there's debris being wafted into the air. We will go over that shortly. Or it has been visually confirmed by a storm spotter. Now, this is unofficial, but generally there are 4 levels of tornado warnings. First off is radar indicated. That just means that the radar is seeing something within the storm that indicates a tornado either is in progress or will be soon. This is usually based on velocity data. We'll look at that shortly. Confirmed tornado means a tornado has been spotted or there is radar indications that it's currently lifting debris into the air. Now, the next level is a PDS, or particularly dangerous situation tornado. This means a large and confirmed tornado is on the ground right now causing damage. And if you're in the path of this thing, damage could be substantial. When you see PDS warnings, this means that this tornado could be significant and it could be deadly. You need to take this especially seriously. And the highest level that they'll issue is what's called a tornado emergency. That means a large and confirmed deadly tornado is moving into a heavily populated area. The first time a tornado emergency was ever issued was on May 3rd, 1999, when the Bridge Creek Moore F5 was moving into the Oklahoma City area. The National Weather Service in Norman, they needed to get the word out that this is not your ordinary tornado. So on the fly, they came up with a new term, tornado emergency. Now that's still used to this day. Some offices have specific criteria that they demand a tornado emergency to be issued. Others just leave it up to the person issuing the warning. So I will always say local news and radio is your best source for understanding the current severe weather threat. The local news channels, they employ chasers, meteorologists, people who know what they're doing, who know what they're seeing, and can get that information out. But I would also suggest having a radar source at the ready. There are hundreds of apps out there that have radar. I would suggest something called Radar Scope. Radar Scope is available for Android and iOS. It's what I use. It's $10 a year, and it uses real-life radar information that you can read, that you can look at. So they use radar from Doppler radar, and the way that works is it shoots beams into the clouds, and that beam comes back to the station after bouncing off whatever's in the atmosphere, snow, hail, rain, whatever. These are the stations across the United States. There's one here in Norman, one here in Vance Air Force Base in Enid, one here in Frederick, Tulsa, and Fort Smith. Those cover most of Oklahoma for the most part. So radar reading it's a little difficult, but I look at 3 main things. Reflectivity, which is the radar beam bouncing off things in the air. Velocity, which tells us where the air is moving and how fast. And correlation coefficient, which compares the size of particulates to each other in the air. And that's really useful in determining if a tornado has touched down or not. So this is what Radar Scope looks like. Here's our supercell. If I just had this this is reflectivity. If I just had reflectivity, you see these higher returns of hail and rain. It has a bit of a hook shape, but it's not particularly impressive. But if I go to velocity mode, I'm seeing these bright greens and these bright reds touching each other. This is called a velocity couplet, and this indicates that there's significant rotation occurring in a very small area, usually indicative of tornado potential. And in fact, this EF4 tornado was in progress at this time. Without velocity data, that would be really hard to say that there's a significant tornado threat. So let's do another case study. This is last year, March 3rd, 2019, the deep south was under a 15% chance of a tornado, of a severe weather threat. A cold front was pushing southward, and anything in front of that cold front was going to be of particular note. So 4 days in advance, they highlight this area. 3 days in advance, they issue a slight risk for the deep south, especially southern Alabama, Mississippi, and Georgia. 2 days in advance, they go to an enhanced risk. They were starting to see that there was a significant tornado potential in front of the line. Now, the line itself was also going to have a tornado threat just because of how much shear was in place, but anything that developed in front of that line could be a lot worse. So the day of the event, they expand the enhanced risk for all of southern Alabama, southwest Georgia, and they were issuing this for a 10% significant tornado chance. This was the air balloon data out of Tallahassee that day, and it's 1600, that's not particularly significant, but the shear was very significant. And again, this was forecasted to be a lot more during the day. So you got a moderately unstable atmosphere coupled with a very sheared environment. The significant tornado potential was there, especially if you get an isolated cell. So the mesoscale discussion that day looked like this, and they were highlighting particularly southeastern Alabama for the biggest tornado threat. So they issued the tornado watch here. Obviously, there was a high risk of tornadoes and a moderate risk for strong tornadoes. 70% chance of of 2 or more tornadoes, 50% chance of a moderate or significant tornadoes. And so the question was, would anything develop in front of the line? And yes, unfortunately, something did. This is Lee County, Alabama, right here. This is where the University of Auburn is. And you have your forward flank downdraft here, but your hook echo is not particularly great. I've seen a lot better than this. So just by looking at reflectivity, I'm not that impressed yet. When I go to velocity mode, there's a very tight couplet right here of high winds away from the radar. Red is winds moving away from the radar. Green is towards the radar. And when they're close to each other like this, that means there's rotation in the air. It's getting stronger. And this is something that the Weather Service has done for the first time last year. They will start highlighting particular storms for tornado potential. So they highlighted this storm saying, there's a strong tornado potential with the sky, pay attention. And those of us who were watching this, our hearts sank when we saw this. This is what radar scope looked like at the time. And we got the rear flank downdraft really starting to wrap around here. And this hook right here was getting more and more significant, and the velocities were getting almost maxed out. When you start seeing these browns, that's as high as this scale goes. And it's close to these bright blues. There was a tornado either in progress or about to be in progress with this. But the way we can determine if the tornado is actually in progress is by looking at correlation coefficient, which is this. And what I would want to see is some dark greens or dark blues or whites in here, indicating that the particles in the air are of different sizes. When they're red like this, that means everything in the air is the same size. Raindrops are the same size. Hail and rain might lower the correlation a bit, so you'll start seeing these greens. But blues and whites indicate there is a lot of different size particles in the air. If you couple that with the location of a velocity couplet like this, that would mean that a tornado is in progress. So looking between those two, it's not clear what's going on, but the next scan told me everything I needed to know. This right here is a higher return on reflectivity. This is a tornado in progress lofting debris. We call this a debris ball. So I don't need anything else to tell me that there's a tornado in progress, but here it's very clear. And couple that with the velocity mode, yeah, even without looking at debris in the air, I know this is on the ground, but we can really start seeing that debris ball show up here, coupled with in the same location as that velocity couplet. So the Weather Service in Birmingham, they issued a PDS tornado warning saying we have a confirmed large and dangerous tornado on the ground. Take your evacuation precautions immediately. And this is one of the most iconic images of 2019. This pink ball here, it's obviously a strong to violent tornado on the ground doing damage right now. I don't need to look at velocity. I know it's on the ground, but the correlation coefficient really shows it. And here they issued a tornado emergency for Lee County, Alabama. This tornado eventually got to the EF4 range, and in this shot, it was currently taking the lives of 23 people within Lee County. This tornado was on the ground for almost an hour and a half and traveled 68 miles well into Georgia. But that's an easy example. What about here? We have a tornado warning indicated by this red box, but I don't see any of that supercell structure that I'm used to. So why did they issue this warning? Well, we can look at velocity mode and really easily see that couplet there. So this is why they issued that tornado warning, but the question is it on the ground? Yes. By looking at correlation coefficient, I can tell you, yes, there is a tornado on the ground doing damage as we speak. And by the end of everything, this was a real deal tornado outbreak. The only killer tornado was that Lee County, Alabama tornado, but 79 tornado reports within 24 hours. It extended from southwest Alabama into South Carolina. There were strong tornadoes in Georgia and Florida the same day. So 4 days in advance, these people had the warning to pay attention. 4 days in advance. So how do we prepare for storm season? Well, the most key thing I can tell you is to make your plans now. Where are you going to go in the event of a tornado warning that you're in? The best place is always underground. A tornado cannot kill you 99.99999% of the time if you are underground in a basement or storm shelter. But if you don't have access to one, the innermost room on the lowest floor of your building is the best place. That's because winds are always coming from the outside inside. So putting as many walls between you and the outside will limit how much debris can hit you. Most people are killed by flying debris in tornadoes. So if you can put as many walls or structures between you and the outside, that's going to limit the threat for you being hit. A perfect example was this gentleman. He survived this EF3 tornado by hunkering down in his bathroom. And this was the innermost room of his home. And of course, that's the only walls left standing. So he's showing Tim Marshall, a tornado structural engineer, how he survived this tornado. He did everything right, and he came out of this situation completely unscathed. Now, I'm not saying this as hyperbole. Cars and mobile homes are death traps. If you're in the path of a tornado, evacuate if you're in a car or mobile home. They will go airborne. Anytime air is allowed to get underneath you, you will get airborne during a tornado. Lying in a ditch is better than riding out a tornado in a car or mobile home because you can lay flat in a ditch and prevent air from getting underneath you, causing you to go airborne. And so I looked at the SPC statistics on tornado fatalities and where they occur. Almost half of the tornado fatalities in the 21st century have occurred inside a mobile home or inside a car. Now, there are significant tornadoes that will knock down big buildings, and you can do everything right, and it may not just be enough, but that's definitely the exception versus the rule. Whereas if you're riding out in a mobile home or a car, your chances of surviving are much, much lower. Almost, I don't want to say zero, but much, much lower. Now, a tornado can do this to a vehicle. Granted, this was the Moore F5 of 1999, one of the most powerful tornadoes ever recorded, but it's clear what a tornado can do to a strong truck. I mean, if you were riding out this tornado and there's just no chance you're going to survive. And this was what's left of a mobile home that was struck by an EF3 tornado earlier this year. Unfortunately, 2 elderly people hunkered down in here and they lost their lives in Louisiana this day. I mean, and it's easy to tell why, because there's just nothing left of this mobile home. So that's why I say, if you're in a mobile home or car, get out. Just get out, go somewhere safer, or lie down in a ditch. Do not ride them out in these cars and mobile homes. And another thing that's super infuriating, never, ever, ever, ever park underneath a bridge during a severe weather event. Wind speeds actually increase under the underpass or bridge because of the wind tunneling effect. And it also causes traffic behind you to slow down. So there might be people behind you trying to get to safety, but because there's a ton of cars underneath the bridge that are stopped, they can't go anywhere. Plus, you're getting in the way of emergency vehicles. So many bridges don't have places to go anyway. People remember the Andover 1991 tornado where people took shelter under a bridge. Well, that tornado actually missed them and they were not hit by the strongest winds. Had that tornado actually struck them, there was not much chance that they could have survived. And they also had these girders underneath the overpass to hold on to. Most bridges don't have those, so you're totally exposed to not only the strong winds of the tornado, but they're actually amplified under a bridge. And this was a graphic that was presented after that 1993 tornado, after several people were killed in Oklahoma taking shelter underneath an overpass. The winds are actually increased underneath this overpass, so it makes a bad situation somehow even worse. Don't take shelter under a bridge. It's not a good idea. Another thing I'll highly suggest is everyone learn the counties to your southwest. So most of the storms in the spring move southwest to northeast. So knowing the counties and the distances from those to you is a great idea. So if a tornado warning is issued in Beaver County, you need to know, is that going to affect me? What if a tornado warning is issued in McLean County or Washington County, LaFleur County? You got to know where these counties are in relation to you so that you can know whether or not you need to take shelter or not. And so what I did was last year I took a Sporkle quiz and just learned all 77 counties in Oklahoma. Now, Oklahoma is nice because most of the counties have character. You know, we don't just have square or rectangular counties like Kansas or Texas, Iowa, Nebraska. Most of them have these strange borders that I can remember. All right, this is Tulsa County. That means that this is Rogers County. This is Washington County. Jackson County looks like this. That must mean this is Kiowa County, and so on. So it took me an hour to learn this, and you know, this is information that might save my life one day. I would also highly suggest getting a weather radio. They will go off anytime, day or night, and alert you to severe weather that's ongoing in your area. So if a tornado warning is issued at 3 o'clock in the morning, you're dead asleep, that will go off, and then you can start taking your precautions, start activating your plan to take shelter. And they're also programmable so that you only have to worry about the counties you're interested in. So if you're in Oklahoma County, you really don't have to worry about a tornado warning in Tulsa County most of the time. So you can program that to only worry about your county and counties to the southwest. So they're $30. You can get them on Amazon, you can get them at Walmart, you can get them anywhere. They're a great idea to have, and a $30 investment that could easily save your life. So one final case study I want to go over was the worst case scenario. This is as bad as it probably can possibly get. And we're going to focus on the April 27th, 2011 super outbreak in Alabama. So 5 days in advance, the Storm Prediction Center was already saying, Alabama, heads up, you got severe weather heading your way. And 4 days in advance, it was becoming more and more clear that this was going to be a significant tornado event. So 3 days in advance, they issued the moderate risk. And a moderate risk 3 days in advance should have set off all the alarm bells. This is big time. This is as bad as it's going to get. Take your precautions now. Get ready. It's going to get rough. There was basically a coin flip 3 days in advance whether or not northern Alabama was going to get hit by significant severe weather. 2 days in advance, they increased the moderate size to include Tennessee and parts of Kentucky. Again, 45% chance. Now, the day of, this is also an iconic upper air sounding from Birmingham, Alabama at 1 o'clock in the afternoon. You have 3,000 K, very unstable atmosphere. Your shear was off the charts, 260 in the lower atmosphere, 500 within 3 kilometers. This was going to be a super dangerous situation. These storms were going to go up fast, they were going to go up early, and they were going to sustain themselves for a long time. So unsurprisingly, the Storm Prediction Center went high risk the morning of the event with a 45% chance of strong tornadoes in northern Alabama. This is about as dire of a mesoscale discussion as you'll ever see, especially when they say a long duration PDS tornado watch will be issued by mid-afternoon. And this is the most infamous tornado watch ever produced. This is tornado watch number 235, issued at 1:45 p.m. on the day of the event. They mentioned destructive tornadoes, and this paragraph here is, it does not get worse than this. A classic tornado outbreak, long tracks, strong to violent tornadoes. It was as bad as it could possibly get, and they knew it was coming days in advance. And for the first time ever, every single severe category risk was maxed out. This is as high as they can go. They knew this was coming. They knew it was going to be really bad. And sure enough, it was. Every single one of these storms was going to produce a strong or violent tornado. There's an EF4 in progress. There's an EF5 in progress. This just produced an EF5, about to produce an EF4. Here's an EF4. Here's an EF4. Every storm was going to be a killer. And sure enough, it was. We had tornadoes from western Mississippi to New York State. There was a line of warning storms that came through this area, really limiting the instability in Kentucky and Tennessee, because the better shear was actually up here in Tennessee, but those storms, they limited the potential up there. But you can already see it didn't matter for Alabama. And this was the final map of all the tornadoes produced. Anything purple or red was a violent tornado. Anything orange and yellow was a strong tornado. But the reason I bring this up is because I want to ask you, what percentage of the land surface in Alabama was directly affected by a tornado on this day? And let me tell you, the answer is kind of surprising. It's 2%. 2% of the surface of Alabama was affected by a tornado. So even in the worst possible case, this may never happen again. It probably never can happen in Oklahoma. But even in the worst case scenario, there's a 98% chance you're going to be fine. But there's also a really, really low chance on outbreak days that someone doesn't get hit. So take your precautions now, get ready, know what you're going to do when the tornado warning is issued. To finalize this stuff, and I'm sorry I've gone over where I wanted to go, but I know someone's going to ask me, what is the forecast for severe weather in Oklahoma this spring? And that's difficult to say, but what we're looking for is something like this. This is real world data from an outbreak that occurred in 2012 in central Kansas and northern Oklahoma. This is the jet stream right here. It's coming down, it's digging south, and there's a low pressure center here in the Four Corners region. It's digging south, and those winds are ejecting into the southern plains from the southwest. So what we generally look for Oklahoma severe weather is something like this. Maybe not to this degree, but you're looking for the jet stream to come down and around the Four Corners region and eject into the southern plains. This is the forecasted look for April. You can kind of see a hint of that southwest, what we call trough. You can see that maybe in place. You have this low pressure system up here, which generally limits the severe weather potential, but it may not matter as much this year. We've already seen indications of maybe not early April, but late April could be somewhat active. There were signs that maybe as early as next week, we could start seeing significant severe weather activity again. Maybe the models have kind of dropped off that idea, but definitely the later half of the month of April is when we need to start really focusing on what might happen, because there's hints that late April could be active. Well, does that mean it's going to be active in Oklahoma? Maybe, maybe not. It might be confined down here to the south. We just don't know yet. But there's definitely a hint of that possibility. Now in May, there's a much better look. You're definitely seeing this digging trough southwest flow into the southern plains. If you're a storm chaser who wants to see tornadoes in May, it's hard to see a better look than this. This has all of us excited. You know, granted, we have the virus problem going on, so we don't know what's going to happen regarding the virus. But if I had to say now, what do I expect for May? I expect it to be at least as active, if not more active than normal. And we add this precipitation anomaly, you're getting a lot more rain in the southern plains than average during the month of May. If you're seeing more rain than average, and you're seeing that southwest trough, that's signaling to me that there's a chance of a more active spring than normal. So when I say make your plans now, I mean that. Make them now. This does not mean you're going to get hit by a tornado. It just means that there's a chance that it will be a more active spring than normal. Last year was a more active spring than normal. So things are starting to come in place, and people have been talking about this for a while now. There's definitely a chance for an interesting spring this summer. Interesting spring in the coming months. So my final thoughts, there will be tornadoes in Oklahoma. As long as there's a Gulf of Mexico, as long as there are Rocky Mountains, as long as there's a jet stream, we're going to have tornadoes in Oklahoma. Most of them will be very weak. They will not last very long. They won't hurt you. A few could be strong, causing significant damage, and even fewer than that could be violent. We've been lucky lately. We have not had a violent tornado in Oklahoma since 2016. That does not mean we're due. We could go another 6 years without seeing a violent tornado. It just means that the odds of you being hit by a violent tornado are very, very low. Severe weather it doesn't happen in a vacuum 99% of the time. There's always, the vast majority of the time, there's forecasters who are seeing it happen. Warnings can be issued hours before a tornado actually occurs. So pleading ignorance is not an excuse anymore. You have to find a way to get this information to you, and you have to know what your plan is. The odds of a tornado hitting you are extremely low, but the odds of no one getting hit by a tornado are also extremely low. So someone will get hit this year. Hopefully they take their plan of action. Hopefully they get safe, and hopefully we can keep the injuries and fatalities to an absolute minimum this year. Know how tornadoes form, have a plan, take your action, and I will see you on the other side. Thank you very much for listening to me talk for way too long. I will now open the gallery to any questions, and I appreciate you guys listening to me. Do we have any questions? No, Jerry, I did not miss my calling. Weather is interesting, but only one type of weather. I do not care about summer weather. I do not care about winter weather. I only care about weather in the spring. So geology is my passion. I love geology. I also love this. I would not want to do meteorology for a job. So Kurt, for those of us with agency phones, what apps would you recommend to stay alert and aware of watches and warnings? The best thing you can do is just visit the Storm Prediction Center site every single morning or multiple times a day during the spring, because they will keep you as up to date as you can on the actual forecast themselves. Now, to actually get warnings, there's tech services out there. So what I'm going to do is I'm creating a list of helpful links that can help you with that. They can actually give you the warning through text, through some alert or something like that. Radar Scope, I highly recommend. I know it's $10 a year, but it's a $10 investment that is really, really useful. I think the National Weather Service, they have their own apps. I know there's a ton of them out there that can alert you. I think there's normal text services by cellular companies that will say, hey, you're in a tornado warning right now. Yeah, so Derek says that the National Weather, or that NOAA, the National Oceanographic and Atmospheric Administration, has a weather radio app. And it's basically like a weather radio. Anybody else? I know that was really long. I'm surprised I still have my voice. But if there are any further questions, if something comes up later and you have a question that if you want me to explain, hey, the weather office says this, what does that mean? Or what implications does that have? I will gladly try my best to explain this. I'm not a meteorologist. I keep saying that. I don't know how to forecast stuff as well as the professionals, but I can try my best. As long as the question isn't, will there be tornadoes today? I will be happy to help you out as much as possible. But with that, I think I'm gonna, oh, sorry.